to invite now Edward Barth, IBM's Business Development for Technology Alliances.
IBM, as Federico pointed out, and myself personally, has been involved in this project since 2004, 2005, and we're very happy to be a part of it and to see the launch of the company now. I want to touch on a few things. I'll move pretty quickly here. First, I wanted to talk about some dynamics in the semiconductor. I'll expand on some of what Alex presented at the beginning. Talk about what's going on in the semiconductor, in different parts of the semiconductor industry, and how IBM has reacted to that, and how we've built a model of collaboration, technology alliances, and joint research and development based on those dynamics. And then finally, talk a little bit about our participation with SICK Semiconductors and what we're doing together. So, of course, as we've talked about, and as Alex talked about at the beginning, semiconductors are a part of our everyday world. They touch on all aspects of life today. They're embedded in everything we do, in our consumer devices, in the interconnectedness of our world, in what we in IBM describe as our smarter planet approach to looking at the world. It has really magnified and grown so that nearly everything in our lives is a part of the data infrastructure in our world. And what's enabled this is the tremendous exponential growth in the capability and the affordability of semiconductor devices. This shows up again, just some more data, not only in the devices themselves, but in the way that our social networks, that our communication, that the way we come together and live our lives has this intelligence embedded in it. I mentioned IBM, starting a few years ago, announced our Smarter Planet strategy. Smarter Planet is a way of looking at the world in terms of the interconnectedness, the embedded intelligence, and turning all of that information into data. This has aspects, this has applications in many different areas, from telecommunication-based infrastructure into making the very cities and buildings we live in and our physical places smarter. Again, this is enabled by this tremendous exponential growth of semiconductor affordability and devices. In fact, if you look over a very long time horizon of computing, even from before the advent of integrated circuits, it's actually faster than exponential. Tremendous growth over the last century in the capability of devices to handle this information and to instrument our world. Roughly speaking, the semiconductor industry is in something like a 10-year business cycle. And it all starts with investment in growth, both in R&D and in manufacturing. And if you look at the data, that rough numbers, that's about 4x over the time in this 10x, this 10-year cycle. That growth in investment in semiconductor manufacturing and R&D leads to 2 orders of magnitude, something like 100x improvement in the cost for function, reduction in cost for the same function, or improvement in function for the same cost, of course. That exponential growth in cost per function leads to increased consumption of these devices in terms of memory, in terms of capability, CPU speed, and now as we look at embeddedness in our consumer electronics throughout our world, all of that consumption is something like 400x over 10 years. That of course drives back into growth in revenue for the companies that produce these devices, which is the engine that brings us back to the ability to continue this investment in manufacturing and in research and development. So this scaling has been a tremendous engine of growth for the industry and for all of us as consumers of electronics over this time period. However, of course, all good things eventually come to an end. We as an industry, of course, have said that before, waved that flag before, been able to come over it. But you know, today when IBM, the other leading edge manufacturers are looking at 10 nanometer technologies, 8 nanometer technologies, we truly are at a point where the end is in sight. So you can continue to scale, to drive down these costs, but it starts to become exponentially more expensive to do so, even beyond what I talked about before. And so that means you have to look at other types of innovation, other ways of innovating beyond purely scaling. And so there's a technological innovation piece of this, finding things other than the brute force Moore's law kind of scaling. And there's also business model innovation, finding ways to collaborate, to partner, to form alliances, to share the risk and the expense of this ongoing development. And this is a recognition that we in IBM internalized a couple of decades ago and have applied to our microelectronics business and now across the company. In IBM's microelectronics business, we are a large, diverse company. Today, in fact, more services and software than hardware. But our computers, our hardware business is still critically important to IBM as a company. And within that, our microelectronics business is critically important to our hardware business. And so first and foremost, the reason that IBM continues to make this investment in the research and development and the manufacturing of semiconductors is to support our mainframe businesses and our scientific computing businesses. But we need to do two other things in order for that to be a practical commercial reality. One, on the lower right-hand side, is to build an OEM business, to build a commercial microelectronics business. We do that at the leading edge, and we do that in our Burlington, Vermont specialty foundry business. The other thing we've had to do over the years is build up a very robust set of technology alliances and a joint R&D model that, as I said, allows us to share the costs, the risks, and the critical knowledge that it takes to make this ongoing innovation a reality. This winds up, of course, in IBM's products and services. Hopefully you all saw last year our great victory in the Jeopardy game show with Watson. I won't dwell on that. But it's not only that. And for IBM and within our microelectronics technologies, we're not solely focused on the leading edge, the kinds of things that go into our supercomputers. If you take a look at something like a typical smartphone, IBM's technologies, including some of the ones that we've shared and are partnering with SICK Semiconductors on, go in many parts of this. And so we've got RF CMOS and RF on SOI technologies for things like the wireless front end of the cell phone. We use silicon germanium technology for the very high-speed RF parts of it. We do use our advanced logic technologies for the baseband, for the application processors. And our high voltage CMOS for things like the power management parts. So within IBM are focusing not only on the leading edge, but on these other applications as well. And so that just as one example, you know, as we look across something like an entire telecommunications chain, from the back office servers, Alex mentioned this as well, sort of the consumption of big data in our interconnected society, but all the way down to the individual sensors and actuators that drive the world around us, the types of hybrid devices that Tino described a few minutes ago. In order for us to accomplish this, IBM's built an innovation ecosystem. We have our own facilities where we do this research and development, and we invite in partners of all sorts, not only other semiconductor makers, but chip design companies, equipment and material suppliers, packaging companies, each segment of the semiconductor chain, and build an ecosystem to do this in a joint and open innovation platform kind of way. As I mentioned, IBM has our own sites around the world. We have some key partners in the semiconductor industry, in other places, and we also have IBM's network of labs in our research division. Most recently, in 2010, we announced our 9th research lab, the first one in 12 or 13 years, to be in Brazil. And they're playing an important role in the collaboration we have with SICK Semiconductors as well. As I mentioned, this ecosystem spreads out not just from other semiconductor makers, but going on to EDA vendors, to design companies, to suppliers, to research institutes all the way around the world. And based on this, and for the last 20 or 25 years, IBM has been proliferating our technology through our partners. We've done it successfully all around the world for 25 years or so, and we're very happy that this year, last year, and this year, we're working on the latest of those transfers to SICK Semiconductors in Brazil. A few more words, expanding on what Tino mentioned about our partnership. As we've said before, we are sharing with SICK Semiconductor the 130 and 90 nanometer technologies that we use in our Burlington, Vermont specialty foundry for these some of the kinds of applications, especially the RF CMOS that I talked about before. We will participate in the training and the support of new employees, whether they're experienced professionals from the semiconductor industry but new to IBM technology, or new individuals. We have a plan to host some of the technical staff of SICK Semiconductors in IBM's plants to help facilitate this transfer and training activities. We've got the joint R&D activities together. Tino talked about the microfluidics project, which has been underway for nearly a year now, and we continue to work on a growing roadmap of new activities that we'll jointly research together. And finally, there's our commercial and manufacturing alliance. As Federico mentioned earlier, IBM and SICK have an agreement where IBM could perform some manufacturing during the startup phase of SICK, or if SICK's products need a technology which is not internalized within SICK. We'll also work together in terms of joint go-to-market activities, identification of customers, markets, and products for SICK.